Hello, in the last class we had gone through an introduction on the graphs of motion, and we had seen that there are basically three graphs that we have to discuss. The first one is the position time graph, position TION, position time graph. It is also called the XT graph, right? And the second one is the velocity time graph, and that is called the VT graph. And thirdly, we had the acceleration time graph, and that is called the AT graph, right? So we had these kinds of graphs, and just take a look at how they are looking like. So in all these three graphs, we have the time on the x-axis, that is the horizontal axis, or which we can also call the independent axis, and the other term is on the y-axis. So for an xt graph, we have the x, or the position, on the y-axis. This is the xt graph. Then we have the vt graph. The vt graph has the same t on the x-axis and the velocity on the y-axis, whereas the acceleration time graph has t on the x-axis and a acceleration on the y-axis. So this was the thing that we had discussed in the last class, and we shall move on from this position forward. Okay, so we'll first take a look at the position time graph. The position time graph is such that for a body at rest, we have the time moving forward, but the position of the body not changing at all. So if the position of the body in the beginning is this, then as the time moves forward 1 second, 2 second, 3 second, 4 second, and so on, the position does not change. The position remains the same. So we have this on the graph. So a position time graph actually looks like this. It looks like a parallel line to the time axis. So when we have such a kind of a look about the graph, we can say that this is the graph of a body at rest whose position is actually not changing with respect to time, right? So after this, we move on to the next type of XT graph. The second type of XT graph is like this. Suppose we have this XT graph over here, and we have a body which is moving with uniform velocity, so uniform motion. So what happens is it will have equal changes in position in equal intervals of time. That is, say if the time is 1 second, then the body might move from position 0 to 1. Okay, so the position of the body may be explained with the help of this point. And so at 2 seconds, then since the body is moving with uniform velocity or uniform motion, so in each second it will move 1 meter or 1 unit forward. So in 1 second it has moved from 0 to 1. So in the next 1 second it will move from 1 to 2. Hence the position of the body at 2 seconds will be given by this position, that is 2 second, 2 units of position. Similarly, in the next second, say in the third second, it moves another 1 unit, and the position of the body will be given by this point. So if we go on in this way, what we will have is we will have a kind of a graph like this, a straight line, but not parallel to the time axis rather, but it is somewhat oblique, but it is a straight line, and it's the line is oblique in this way. And this is the xt graph of a body which is actually in uniform motion. So let us write it down. This is the graph of a body body at a uniform motion, right? So this is the second type of graph, second type of xt graph rather. We have some other types of xt graphs also, and another type of xt graph is like this. We have the x on the y axis and t on the x axis as usual, and then now suppose the body is not moving with uniform motion, rather the body is moving with non-uniform motion, then the graph will look like something like this. That is, it will have some kind of a concave structure over here if the body is moving with positive acceleration. So this is for positive acceleration, okay? And if now, since it is positive acceleration, we know that the velocity is increasing. So this is the xt graph of a body which has non-uniform motion, and non-uniform motion also of this type, that is positive acceleration or velocity is increasing. We can also say that the acceleration and motion, acceleration and velocity are in the same direction, right? So this is that kind of graph which shows this kind of motion. Another type of xt graph is, again we can draw it in the same way with the x, that is the position on the y-axis and the time on the x-axis. This time the graph will look something like this. It has got some kind of a convex structure over here, and this kind of graph is also for non-uniform motion, and but this is for negative acceleration, right? And negative acceleration actually means that the velocity is decreasing, v is decreasing, and when v is decreasing, actually we have the acceleration and the velocity in opposite directions, right? So these two graphs are for non-uniform motion, while this graph is for uniform motion. I'll just put it over here that these two graphs actually represent non-uniform motion. So these are, I'll put them together in one box, and we can write down over here that these two graphs represent non-uniform motion. So these are the different types of xt graphs that we often come across. 4 types of xt graphs. We shall take a look at the next kind of graph, that is velocity time graph. But before that, we'll take a quick break and come back very soon.